Okay, so we are now reaching the final stage of building our cross-section. Before we get into that zone of complexity here, I just want to highlight a couple of points. So you always draw from the youngest to the oldest, so you've probably put your two faults that seem to cut through everything. You've put your faults on your section. Then you draw your recent sub-horizontal succession. And and then you get into the unconformity and you start drawing what's underneath. I just want to highlight one thing. So this is a very schematic diagram, but let's imagine that we've got a succession like that, and we've got an horizontal succession that we find on the other side. So we're drawing these things. And let's say that we've got an unconformity here with rocks that are deformed underneath. So in that case, I think what is important to keep in mind is that, okay, you may see some of the, let's say that we see that the rocks are bedded in that direction, for example, and we see that there is a fold like that, for example. What I'm trying to say here is that don't draw too far away from the unconformity, because we don't really know much what is happening. Well, except if you see on your section, on your map, you have a window of what's happening when you go away from the line of section. If you don't know, if you're not 100% sure, stop drawing when you are under that unconformity. So I drew an unconformity, a sort of irregular contact here. Here it's okay to draw these lines horizontal across the whole line of section, because we know that the whole succession is horizontal. Here we have something that is deformed. This here may keep going this way, or it may be folded this way, or we have no idea, there may be some faults across. So what I want to highlight here is that just draw close to the, just draw in the area where you are pretty confident this is what's happening, but don't extrapolate too far if you don't have much evidence to determine what the structure is. Okay, so that zone of complexity. So something that is quite good to do sometimes when you've got zones of complexity is to try to take a piece of paper and just draw that zone of complexity and try to think about, okay, what is happening here? So I've drawn that here. What we have here is, so we've got the valley is here. We've got the Tapit sandstone here. We've got this we've got a bit of that intrusion. The red one is here. So we've got a bit of the Rama formation here. We've got the Hakatai shale. We get into this Bass limestone. And then we've got this second unconformity. And underneath the unconformity, we've got that Brahma schist just underneath here. We get on the other side, we get the limestone carrying on just as a result of the topography. We've got that fault, and then we get more of this Brahma schist here, the limestone here, that second unconformity, and the Tapit sandstone. So this is typical. This is what what it looks like when you put it with the topography. So we've got that valley here. And the reason why we see the Brahma schist at the bottom of the valley is because the erosion went all the way through the two unconformities here. So we've got the unconformity here with the Tapit sandstone on that side. Sorry, the Tapit sandstone are above here and here. We've got that red unconformity, the first one. We've got the Hakatai shale. We've got the limestone here. So you're thinking about, if you're thinking about, okay, in which, how much, we said that this unit was dipping in some direction. If you look here, you've got dip symbol that indicate 13 degrees towards the northwest. So that's perpendicular to the line of section. So remember, when the beds are dipping perpendicular to the line of section, the beds are going to appear horizontally. So that's why I drew them horizontally. And here we've got our limestone here coming up. And here I drew the fault with a steep angle here. And then we get on the other side. So on the other side, we've got that schist here. We've got the limestone appearing here, and then that second unconformity is here. So let's think about what happened here on this fault. What is the result? So here we've got that basement, the Brahma schist. nearly vertically foliated. So that's what I try to represent here. We've got that fault, and you can see that the offset, what I'm asking you is, what is the offset on this fault? Is that a reverse fault or is that a normal fault? So think about that for a few minutes and then come with an answer.